So, hello everyone, I'm Satyapriya and I'm currently doing my master's in astronomy and astrophysics. So, I thought that there are currently no as such a proper tutorial, brief tutorial about how to use the TOPCAT. So, because of that, I thought I will make a small tutorial for you, for everyone, so that it will be accessible for and useful for everyone. Yeah, that's all. Let's start. So you can search the name word TopCat. So this is the website, and as you can see, this is a graphical interface that can be used to for analyzing the astronomical database. There is another like another counterpart of TopCat, which is Silt, which you can use as a command prompt based one, like via that you can as a script you can write all those things. Here TopCat is an interactive one, so if you want to use this for your astronomical purpose, it will be really useful. Why? Because you can open all kind of files like fits files, VOtables, like CSV, text, all those kind of tables you can load, and it can be really huge also. That won't be also that also won't be a problem. And apart from that, all sorts of analysis like applying constraints and like selecting columns, like doing math, any kind of mathematical operations on them, and like all kind of like plot for the purpose of plotting and doing cross match with those all those catalogs that you have via various methods, like combining them. And you can also do cross match with online catalogs. There is also ADQL option also that you can use, so you have a lot of options with you. So with that we will move ahead. So how to install it? So first of all, you have to go here, and there are a lot of documentation, FAQ also that you can see, and here are some tutorials also. Yeah, you can see that. Now what you have to do is go to this download, and you can download any three of them. So anyone is fine. Like I will typically say you can download the extra jar, so that you will have everything with you. And apart from that, you have from the Oracle website, you have to install the GRE file. So .gre file like is one of those files. If you install that, then you can run all those programs like which are written in Java. So since this is a program which is written in Java, and there are a lot of similar uh, such softwares which are written in Java, so you can directly run them uh, by installing this. So once you can go to the website and install it. Once that is done, then what you can do is uh, then you can download this jar file. This file will directly run. So once that is done, you can directly run this. So in like I'm talking in Windows and Unix, you can write this command and then run it. Uh, so you can write in command in the terminal, and then you can then the TopCat window will pop up, and then you can do your analysis. Okay, so I have already installed it. So now we will directly jump to that, and we'll have a quick look at how things work there. Okay, so yeah, where is TopCat? Yeah. So this is how TopCat looks. So here, as you can see, we have a lot of things. First of all, you have to load table. So you can load table, open a new table from here itself, or just go to this. So you can load table. So I will go and load one of the table for my data. Let's say I have this data. So it's a VOT file. So that will also do. And any file will do. What all data you have, it can load tables up to millions and like in billions, so it is really useful. So I have this table, so you can click on it. So it will show you the data. Okay, as you can see, these are the data. Okay, so as you can see there, this is all the columns and all everything. They can load very big tables here. So we have the data with us. Now let's move ahead with this single table only. So what we can do with this? So there is this option which shows display column metadata. So here you can see all the columns column name. You can change the column names from here. Here you can see there is this ID. You can use the ID or the name itself. So for like applying some constraints or for any kind of analysis that you want to do, you can use these two. And here it gives a whole description like what is a class, like what sort of value it is. Here it is a string because it's a name. So and here it is like double float, etc. And these are the units. So nice. We can use this here. Here it is the row subsets. As you can see here, with this plus, you can define a new row subset. So let's say from this column, what I want is for this error ellipse value is $5. So I want that uh, uh, let's say error subset. Now I can like make a subset where I will say that okay, if there's error, if this column value is less than 4, then take it. And you can like write multiple columns, sorry, multiple such conditions, like you know how to write condition statements, right? Using and or. For or you will give the this line, I don't know what's that called. Okay, whatever. So you can apply all those constraints, and then when you will this vertical line, yeah. So I don't remember still its name. Okay, anyway. So once you apply this, set it to okay. Okay, as you can see, this gives you what's the size, what's the fraction, and you can use this expression. Now you can write much more complicated such conditions. Like you can use, there are a lot of functions available here in TopCat which you can directly use for to give more such complicated conditions. Um, Now and you can use these names like of this condition for like further conditions. Let's say you are giving okay this name and some other criteria. This is what I want, or the this subset and this another one, or this one. So what it will do is if you have to like do modifications in one of them, then what you can do, uh, like you don't have to do changes in all of them. You can do simply do change to one of them, and then it will do all the changes. So once that is done, you have your subset. So you can a row subset, you can choose the row subset from here. And if you have the table, you can make row subsets from here itself. So if I choose this many rows, I want to make a subset out of this. So I can like let's give a name. Let's say A. I don't know, some random name I gave. So yeah. So this makes another subset. Now uh by this you can also do it. And what you can do is like uh right click on a column. It will show that select make a new synthetic column. So you can make synthetic column also, and you can sort the column also. So and hide the column, whatever. What all thing you want to do, you can do it here. So once this is done, uh, you can like make subset here and all everything you can do it. Okay. And if you want to know the general statistics, so what you can do is you can go to this general statistics column. So this button. So if you press this, it will show you the general statistics of each column, that what is the mean, standard deviation, minimum, maximum, and the number of points that. So as you can see here, since I've selected the subset one, uh, some random subset A. If I give, uh, if I select all, it will show me for all columns. for all rows. So that this can be done. Now, moving ahead, we can do plotting also. So there are a lot of options for plotting. One is this is histogram. This is for like 2D plotting. This is for the sky plotting. Like um, in astronomy, we are covering the whole sky and we want to plot and see, okay, how much sky coverage there is in that. And let's say if you have because that is the projected version, and let's say if you have like the RA deck, and apart from that you have like the Z value also, or let's say the distance value. So if you want to plot in that way, so if you want so for that you can use this cube, or for any three column, that's just a 3D plotting you can use, so for that plotting purpose. Next, uh next what we can do is, okay, I think now it is visible. So next what we can do is we can, yeah, first polar coordinates you can plot by here for time series, and this is for matching table. Let's say if you want to match tables. So there are a lot of algorithms here. So this is one useful thing. So here in Sky, you can give a maximum error value in like whatever units you want to choose, and then you can select two tables. So for now I'm just telling you I'm not going to do it. So here you can select any two table and you can specify the array deck and all those other details if you select some other matching algorithm. So what it does is, so here in Sky, so let's say you have like one source and one catalog, and there are like bunch of sources in some other catalog. So what it will do, it will take this one source and it will find the angular separation from the other source using the formula that we all know. So once that is done, it will try to apply a cutoff of that maximum error value that which is given here. So based on that, it will select the best match. So you have an option. So if you want to find the best match, and here you have best match for symmetric, best match for table one, best match for table two. So it means that for one value in table one, so what it'll do is it will find in this error circle, it will find all those matches within that, and will see what is the best match with respect to this. And it will do the similar thing in from the point of view of the other catalog also. So this gives with respect to table one or with respect to table two. And if you want for like a symmetric match, that it okay, it is the best one with from here and from here also. So that is the best match symmetric option. And if you want all kind of matches, okay, I want all possible matches for this, all possible matches for that, so you can select all matches. What it will do is it will give you the uh, uh, all matches, and it will be grouped. So for easy navigation, it will be grouped, so it will give you group number, and in group number will be, there will be a group number for each source of like the table one. And then for the table 2, if there are multiple matches, it will show like table 1 data will be multiple time, and then the table 2 data of for the corresponding match will be there. And then the group number will be the number for this like table 1, and the group ID, some other value will also be there, which will show that okay, what is the count for the like number of matches for from the table two. So it will be 1, 2, 3, 4, 5. And for let's say for the another source, there is five more. So it will show 1, 2, 3, 4, 5 like that. Okay. So this is this. Next we can do is like take the sky with error algorithm. In this, what we'll do is, okay, till now we just took one simple cutoff. Considering both of them are just point source, like we have only arithmetic. Now, what we want is, okay, as we all know that all the instruments, they are not perfect. There will be an error circle associated with it. So let's say you know the error column value, or you know just some astrometric uncertainty which is there. So so if you know that value for the instrument, so you can give one some simple number here, you can give a number. Okay, so you can simply write one number here. Let's say I give 1.73. So it will take 1.73. And if you have a column, then you can select the column also. So once you do that, then you can select this matching selection and joint type. Yeah, the joint type is another thing you can do. One and two, one or two, all from one, all from two, all those things you can do. So how you want to join your table? You want only up for those which are there in one, and there is no corresponding match in two. So you can do that. All kind of things it can be done. So once this is done, okay, so what how it works is, so it will take the error co error column value. Let's say you have two sources. You have an error column, and then there will be another source in the associated table, like the other table, and then there is an error associated with that. Okay, so let's say these two sources are like this. So if the what we'll check is if the sum of the error values is lesser than the no, it will do that in the first case. Okay, no, it doesn't work here like that. It works uh it checks the overlapping. Okay, here it checks how much there is the overlapping of those error ellipse error circles. So I think this is how it works. Yeah, I think that's how it works. So it will check that, and error ellipsis, it won't be circle, but it will be an ellipse. So we have two ellipses. So it will check how well those error ellipses are overlapping. Based on that, it will do the matching. And yeah, this is this method. And in Sky 3D, you can give like another, like the distance column also, and exact value. Yeah, this is pretty useful. So let's say you have one column, one some data. Um, let's say you have Gaia data with you, and in Gaia data, uh, there is some another Gaia catalog in which they have given you just the name, okay, and some analysis value that they did. Let's say it's a black hole catalog, so and that they gave you the name, and it's a quasar or not, and few other columns also. Okay, so you have that table, and another you have data from the full Gaia catalog, actual catalog, DR3 catalog. So now you want to match them, you want this data with that. How will you match it? So what you can do is you can like give the column that you want to match, and then select. Okay, so then what it'll do is it will match it based on that. Okay, so this is how it works. And similarly, you can do Cartesian, a Cartesian with ellipse and isotropic matching, and sky with x, sky with xy. So in X, you can, like with sky, you are giving another constraint on another column. So and in XY, you are giving constraint on two columns. So like that, you can proceed. So this is some basic understanding of how it works. So it will be really useful. And you have this CDS X match. So this is really useful when you want to do cross match with online catalogs. So how it works is that here you will select your table, and then you can give it works on the algorithm of sky only. So here you can like give the radius, search radius, and what we'll do is what you want to find best all match, uh, best remote. So you can do all those things. Then you can give this search radius, and if there is for duplicate, you can do this, and you can choose that for which Vizier table you want to do the cross matching. So here you have Simba, Tumas, all kind of, there are a bunch of catalogs here. So you can select that. Let's say I'm selecting this. So what we'll do is it will give you the few details here. Now you can do the cross match. Here, we can select the block size. Okay, in one go, how many rows will be uploaded to the server, and it will do the cross match and save it. So this is how it works. So it will do it, save it like temporarily maybe, and then move on to the next block. Do it, save it. that's how it works, and then it will complete it. So, or else if the table is like really big, you can just save it into smaller parts and then do this if it fails to work. Okay, for very big tables. Okay, so you can work with you can do that, and there is this function. You can see what it does is here you can see that here we have arithmetic. So for absolute value, maximum between those two, let's say you have two columns. You want to give, okay, A, column B. What's the give me the maximum amount from those two. You can do that, or some particular value also you can do. Maximum, and you can explore like minimum between some like two and t and period. So you can do all those things like round it, round up, round down, find the mod. You can do this. And then here it's in terms of bits, if you want to do some analysis, it can be done. I have mainly used this arithmetic few things. And then there are some like array related thing. If your data is array for every value in that row, it's an array. For the in that column, all everything is an array in each row. So you can use this. So it will for array related analysis, mean, median, etc. So it can do all those things. Next is like conversion. You can convert things from one data type to another, just like in Python. And yeah, this is the useful thing. This is one of the most useful thing. So you can do convert the coordinates. So let's say if you download one data table from the internet, there the data is given only in DMS format, like in degree, minutes, seconds. So you want to convert it into degrees because you want to do some analysis in which it will require you to uh, uh, give the data as an input and degrees. So what you can do is here you can here you can give that column as a input, and then it will convert it for you. And similarly for RAI, you have HMS to degrees that can be done, and degree to DMS. Both kind of conversions can be done. And here you can find the polar distance, angular separation. With the sky distance, you can find the angular separation. It will return the value in degrees. You can multiply it with 3600 so that you can find the value in arc seconds. Okay. In the and defining the new column, you can give this as an input, and then it will do it for you. And with this, you can find the separation for, let's say you did a cross match with two tables, and then you want to find out what is the separation between these two corresponding sources. So that can be done. So this, and then coordinates and radians. So if you have to do your full analysis, all the kind of analysis and degrees for that, this is there. And if you want to do it in radians, this is there. Okay. So this is coverage, this is distance. So if you have like if you want to see all these things are sort of bit of a rough thing. So Z to age, Z to distance. So it does some sort of approximation, then do it. So use it carefully. And yeah, it can find co-moving distance, luminosity distance, look back time, all those things that you can calculate based. So yeah, there are some assumptions based on it that it works. So check the documentation, then do it. Next, there are fluxes. So if you have like things and absolutes and you want to convert into Jansky, if you have an AP magnitude to Jansky, so you can do it. All kind of things. So Johnson filter based some data details are there. Then format if you want to change. And here guy related, I haven't used much, so I can't give. And here are a lot of things. Like the math is a useful thing for me. I've used maths, so all kind of mathematical operation you want to do can be done here. All of your symbols, constants are also there that you can use directly as it is. And there are a few other things also that one can explore. Okay, so this is this. Next, what we can do is plotting. Go for plotting. Okay. Okay, so if you take this, what you can do is select the X column, and you can weight it also, like you want to weight it with respect to some other column that you have. Okay, if you can, that can be done. You can draw subsets here, that okay, I want this subset, I want that subset. It can be done. Okay, so So that can be done. As you can see here, uh, we can take this, let's say we can take this array column. Okay. So you can see this. Now, so this is the distribution. This many sources are in this array like that. Okay. So you can take the give the subset and you can choose the color. You can give the label here, what all label you want to give, and you can like choose the font. So you can choose the font that okay, and you can select the transparency, how transparent this thing has to be, and what kind of plot you want, like sum, count, mean, median, whatever, and it can be filled, open, whatever you like, the thickness, how the line style should be, subset style, etc. And next, what you can do is this is the slits command. I told you right about slits. And now you can change the binning here. So see, changing the bin, how it looks like and changing the bin. And here you can change the scale. So if you want things to be in logarithmic scale, you can directly select here. Okay, it will make things logarithmic for you. You can flip this x-axis, y-axis. This will be useful while in plotting a chart diagram, let's say, because right, you want it to be in increasing order of flux, but since it's a magnitude, it will be negative log. So that's why it will be useful in that. Okay. Now legend, you can select the legend location. It can be external, internal, and you can just select it and drag it wherever you want to keep it. And in axis, you can select the grid. Draw grid, it will draw grid for you. How transparent it has to be, you can choose that. Ticking you can change, range you can change, label you can change, font you can choose how you want things to be. Okay, so this is basic things about this histogram plot, and then in 2D plot, what you can do is similar thing can be done. So you can choose two axes, x-axis, y-axis, draw subset, like plot the subset. Similar thing, you can choose the font. Here, interesting thing. Here you can choose what type of mode you want to mix. If you want to plot a density plot, so it is really easy. So let's say you have a lot of points. So in Python, you have to write a code. Here you don't have to do that. So you can choose that the density, and then you can plot it. So you can do weighted also. There are a lot of options. In subset, you can choose it and see in the forms. You have a lot of options. If you want to uh, draw various kind of plots. Let's say you want to draw contour, you want to draw XY plot. So everything can be done here. So vector plot. So all kind of plot you can choose. Let's say you want to plot those error ellipses. So you can choose this XY error ellipse. What it will do is it will take the input as RA tech and all this positional like error position value like semi-major, semi-minor, angle, certain like to the orientation of the error ellipse, and then it will plot it for you. So all these things can be done. Then you can like in the text you can choose okay, it's labeling whatever. You can explore it. It's basically based on the exploration only. And here you can plot some function. Let's say you want to plot a horizontal line or vertical line or x is equal to y line, whatever you want to plot, you can directly plot it from here itself. Next, you can choose the pointer size, the color, etc. And uh, and the similar thing as the histogram plot. Next, interesting thing is you can directly draw freehand region from here. Let's say I selected this and I draw this. So now I can give the subset name, or what I can do is I can uh, make subsets various way like blob subset, algebraic subset. In algebraic, I can draw like a ellipse, a polygon, whatever I want to draw, I can draw it directly from here, and then I can make a subset. So it will be really useful if you want to visualize thing, and from the visualization, you want to find you want to make a subset directly from there. So it will be really useful. So in that and they can save it. Okay. Now for the plot, you can do all those things. and then export the file, it will save the image. So this this what it is. Next you have in this view, you can see you have Vizier. Everyone knows Vizier. So in this Vizier, you can directly access Vizier table. So if you give the object name RED or REDEC, and then you can search, give the keywords or what survey you want, or some, you can, all those things you can choose. Once that is done, let's say I give M106 and I select it, it automatically gives this, and I can give 5 arc minute, let's say. Now I can choose, okay, I want data in radio. It will search it for me, and it will find all those tables from Vizier, and I can select, okay, I want this table. It will load that table for me directly from there. You can access all the online catalogs from here one way. For image query, you can use this. Spectral query, you can use this. I have not explored these two, so I can't comment much on them. So one is this useful thing, and another one is tab query. So you might have heard about the SQL. So similarly, here we have ADQL. So this is for astronomy. This is similar way only that we write, and here you can like give the keyword, and then let's say give Chandra. See, it show a lot of services so that you can choose what you want, what all catalog. So this is the metadata. So it will fetch the metadata. Then from the metadata, what you can do is you can select the tables one by one, and then from the, it will show the details of the table here, columns here, and all those things. In hints, it will show you how to write all those things, like how to write the SQL query. And you can write just like SQL that, okay, from this table select this many rows, and where the criteria is this, like that you can explore this. So you can use this to get the various catalogs from all over the internet directly to your TopCat. So that's all for today. I think this will be really has helpful to a lot of people. You can save, yeah, one last thing, that you can save table or save the whole session also. Okay. So save the session, what all table you want to save, and then when, if you close the TopCat and you have done some halfway analysis, then you can directly load the session and do your further analysis that you want to do. Okay. So that's it for today, and I hope it will be really useful to everyone. Thank you. Bye bye.